Scenario: a Formula One team is experimenting with a new tire. The driver drives the car at different speeds and records how fast he can enter a circular curve without slipping off the track. Question: how should the team use the data collected to determine the experimental value of the coefficient of dynamic friction between the car's tire and the racetrack? Here's the data provided. You're essentially trying to solve for mu. Here's the answer. The centripetal force is in the x direction, so you can set up the equation. Here it breaks down to mv squared over r equals to mu mg. The only force that is supplying the car to stay on the circular path is the force of friction, mu mg. The masses cancel out. Here you should already see it. The v squared, which is in the y direction, and the r, which is on the bottom, is in the x direction. You should notice that the v squared over r is the slope of this graph. So the mu mg can be determined by looking at this graph and looking at its slope. So you want to determine the slope of the line of best fit, because notice the data are all over the place. So you want to draw a line of best fit, which is a straight horizontal line right here. And if you calculate its slope, you can now set that equal to mu g. And this should not be mu s, it should be mu k g. And that will get you the coefficient of the dynamic friction. Okay, this is actually a real life problem that Formula One drivers use when it comes to determining the grip of new tires, because they will go and use different tires for different race environments.